All right. So you know that the derivative of sine is cosine, the derivative of cosine is negative sine, and we're going to do the last 4 today, and then you'll just see the product rule and the quotient rule working with those things too, and finding tangent lines, and finding normal lines, and doing velocity and acceleration. All the stuff you know how to do, now you just have more new derivatives to do it with. So that's what you're going to see for the rest of chapter 2 and then all of chapter 3. It's going to be all the same things, tangent lines, normal lines, motion problems with new kinds of derivatives. And then you repeat, and then you repeat, and you repeat. So you just keep adding. It's like having a little tool belt, and it's like, oh, I have my tools now to do trig functions. I was only on polynomials, now I've moved on to trig. All right, here you go. Let me just give you the answers to these derivatives, okay? One thing you should know, if you picked up on that yesterday, is that this one's going to be negative and that one's going to be negative. Okay? Those are negative because their prefixes are co, and anything that's co has a negative derivative. So just keep that in mind. All right, the derivative of tangent is something you'll have to memorize. It is the secant squared of x. That is the derivative of tangent. It's just something you're going to have to commit to memory. If you forget it, I'm going to show you a way to figure that out. Okay, if you just have a total brain cramp during a quiz or test, I'm going to show you a way to remember that. Okay, but if the derivative of tangent is secant squared, then there's a pattern to what the derivative of cotangent is. Okay, it is cosecant squared with a negative in front. Okay, there's definitely patterns to how these things go. All right, the derivative of secant. Something you'll need to memorize. It has a secant in it as well, except it's not secant squared. It's secant times tangent. Okay, look at these here. Just that part of it. Okay, do you see 2 secants and 1 tangent, right? It's the same thing here. Okay, there's 2 secants because secant squared is secant times secant, and 1 tangent. That's always the way it goes. There's always 2 and 1. Just get them in the right position. So when you've done tangent, then all you have left is secant times secant, and when you do a secant, then you've got 1 secant left and a tangent. All right, so then if that's the pattern, then what do you think the derivative of cosecant is? Negative cosecant x and times cotangent x. All the cos go together. Okay, those are your final 4 trig derivatives. Okay, so let me show you how to remember these if you just blank out. Okay. Okay. If you forget what the derivative of tangent is and you just can't remember, then change tangent into its trig identity. What's its trig identity? Sine over cosine.
Oh, and then you just do the products.
Quotient. Right, one of those.
Divided.
Right, and then you just use the quotient rule.
Yeah.
So the derivative of tangent can be found by applying the quotient rule to the identity sine over cosine. So that means we start with cosine first, okay, and then multiplied by
Negative cosine.
okay, are you sure it's negative? The derivative of sine, we did low,
No, it's just
d high. Okay, so it should just be positive. Okay, then comes our minus, and then high, d low. Okay, the d low, that's the negative.
Oh, but then they become 1.
Yes. And then we have cosine of x squared. So then my numerator is cosine squared of x plus 2 negatives makes a positive, sine squared of x over the cosine of x quantity squared, or squared. All right, and so you're right. The numerator is 1. and the denominator is cosine of an x squared. And then this is a reciprocal. So 1 over the cosine is the same thing as secant, and that would be squared instead. Okay, because 1 over cosine is the same as secant squared. So now oh yeah, right, the derivative of tangent was secant squared. And that works for all 4 trig derivatives. Okay, any of these can be proven if you take the derivative of their identity. So how would you take the derivative? What identity would you use for cotangent?
Cosine over sine?
Yeah, you'd do cosine x over sine x. And you take the derivative of that using the quotient rule. That'll get you this one. Okay, if you wanted to do secant x, what would you take the derivative of? What's its identity? 1 over cosine x, and then you would use the quotient rule on that. And that would match up to this one. Okay, Ethan?
Is secant x squared different than, like in the parentheses, different than secant squared x?
Nope, they're the same.
Nice.
So he's saying, like, is this the same, and is this, like, putting your square where you put it? They're the same. It's like square root of x versus x to the half. They're the same thing. Okay, any other questions about that proof? Okay, so a couple of those will show up in your homework too, like to prove the other ones. Okay, so let's just practice. Find the second derivative. Okay, Kaylin, can you find the first derivative?
Negative cosine of x.
Okay.
Plus, or minus cosecant x times
Minus, you switched it to minus, okay.
cosecant x times cosecant x.
Okay, very good. All right, that is the first derivative. Cosine of x by itself, and then minus the product. Okay, I'm going to put this product, okay, so minus the product of cosecant x, cotangent x, because that's going to be important for us finding the second derivative. Okay, the second derivative, looking at the cosine, I can just go negative sine, and then minus. Okay, now to find the next derivative, I'm going to need the product rule within it. Okay, so what do I start with? Okay, cotangent x times the derivative of cosecant again,
Oh.
which is
Thing. Negative cosecant x times cotangent x.
okay, plus, okay, now the product rule for that. So now plus cosecant x times negative cosecant squared x. And then big parenthesis to finish that out. Okay, now it's probably going to be a multiple choice, and you're going to have to match your answer to the right one. So the multiple choice answer will have cleaned this up a little bit. So what has to happen with this negative here? Has to be distributed to that quantity. This is a quantity a whole, and then has to get distributed to this one, and that's a quantity as a whole. So I will have the little negative sign of x sitting out in the front. Okay, then what comes next? A plus. Okay, why is it a plus? Because I've just distributed my negative to the quantity that was multiplied that had a negative in it already. Okay, so I have cosecant x, and then how many cotangents? 2. So I can write that as cotangent squared, or I can write it as parentheses cotangent squared. However, okay, then what's the next sign? A plus or a minus?
Plus.
Okay, a plus again. And then what do I have here? Cosecant cubed x, or parentheses cosecant x quantity cubed, either way. Okay,
That's it, right?
that is it.
That's like burning a banner on this one.
Okay, great. Okay, so here's, find the tangent line 2, and you're like, okay, I know how to find tangent lines because every tangent line, no matter what I'm finding the tangent line of, is still the same process every single time. The tangent line means I need a point and a slope. All right, so our point is going to start with pi fourths, and then is also going to need the value of pi fourths when plugged into the secant function. Okay? Now you've rationalized it. Is that necessary? No. Okay, so 2 over rad 2. Which you may rationalize if you like, but you do not have to. Okay, so how did he get that? Well, Christian, I'm imagining he found the cosine of pi fourths in his head first. Cosine of pi fourths, I know that's rad 2 over 2. And then he just reciprocated it. Okay, inverted it and found the value. Okay, now we want to find the slope. In order to find the slope, we need to first find y prime. Y prime, we just learned the derivative of secant is secant x times the tangent of x. And now we want to find what the secant of pi fourths is and multiply that by the tangent of pi fourths. We just did what the secant of pi fourths is. The secant of pi fourths is 2 over rad 2. What about the tangent of pi fourths? Is 1. Okay, so just 2 over rad 2. Again, don't need to rationalize. So my tangent line would use those things. Y minus 2 over rad 2 times the slope, which is also 2 over rad 2, and then times the quantity x minus pi fourths. You don't need to rationalize, you don't need to distribute, you don't need to simplify. Any equivalent answer is fine. All right, any questions on that one? Big bus. Okay, find the normal line 2. Okay, find the normal line. All right, so we need a point, and we need our slope. Is that JV volley? JV and brush, okay. All right, so we've got pi, and then we're gonna need tangent of pi divided by pi. All right, so we know pi is our x value. What are our y value turn out to be if you know your trig? 0. The tangent of pi is 0, and no matter if you're dividing that, it will still be 0. All right, to find my slope, I'll need to find y prime. So what rule am I going to force you to practice? Quotient rule. So the quotient rule is going to start with x. And then it's going to require us to know what the derivative of tangent is. Secant squared. And then minus, and then tangent of x. And the derivative of x is 1. And the whole thing will be over x squared. All right, so now we're going to find the value of the derivative at pi. So it'll be pi first times the secant squared of pi. Or you can do the secant of pi and then squared on the outside. Okay. Minus the tangent of pi. In fact, maybe you don't even want to do the secant of pi squared. Maybe you want to change the secant of pi to 1 over the cosine of pi, however you want to do that. All right, so I have pi times, okay, well, what is the secant of pi if you know what the cosine of pi is? Cosine of pi. Cosine of pi is -1. But what are we doing to that -1? I thought I was writing the square when I got the phone call and didn't take it, so. Okay, all over pi squared. All right, so what's my numerator?
A pi.
Pi. What's my denominator? Pi squared. So what's my whole thing?
1 over pi.
1 over pi. All right. That is the value of the derivative. It's not the value I'm actually going to need, but it's going to help me get there. So now I'm ready for my normal line. And my normal line is y minus the y value, which turned out to be 0, the normal slope,
Negative pi. Just pi. Oh yeah, negative.
negative pi, and then times x minus pi. Okay.
Kind of comfortable.
Kind of what?
Uncomfortable.
Uncomfortable because you're not comfortable with unit circle?
There's too
Or
many pies.
too many pies. Okay.